Hello everyone, welcome back to my channel. I am Bhagyashree, studying BE second year at Sri Venkateshwara College of Engineering, Bangalore. Now I am here with another topic, Latin square design and in mathematics. Introduction to Latin square design. Latin square design is a mathematical concept used in experimental design and combinational mathematics. A Latin square is an arrangement of symbols or numbers in a square grid where each symbol appears exactly once in each row and column. Latin square have applications in various fields, including statistics, coding theory, cryptography, and Sudoku puzzles. Properties of Latin square. Latin squares have the property of orthogonality, where no two symbols appear in the same position in any row or column. The number of Latin square of size n is denoted as L, and it grows rapidly as n increases. There are no known formulas to calculate L for arbitrary n, but there are various techniques to generate Latin squares. Construction methods for Latin squares. One method to construct Latin square is the direct method, where the squares are constructed row by row. Another method is the recursive method, where smaller Latin squares are combined to form larger ones. There are also algorithm and computer programs available to generate Latin square efficiency. Latin square design in experimentation. Latin square design is used to experimental design to reduce the impact of confounding variables. In Latin square designs, treatments or conditions are arranged such that each treatment appears once in each row and column. The design reduces bias and follows for more precise estimation of treatment effects. Applications of Latin square design. Latin square design is used in agricultural research to test different treatments on plots of land. It is also used in clinical trials to compare the effectiveness of different treatments on patients. Latin square design has applications in industrial experiments, psychology studies, and quality control. Latin square and Sudoku puzzles. Sudoku puzzles are a popular application of Latin squares where the goal is to fill 9 into 9 grid with the numbers 1 to 9. Each row, column, and 3 cross 3 subgrid in Sudoku puzzles must contain all the numbers 1 to 9 exactly once. Latin square provide the basis for the logical and combinatorial aspects of solving Sudoku puzzles. Orthogonal Latin squares. Orthogonal Latin squares are Latin squares that can be combined to form a large square where every pair of symbols appears exactly once in each position. Orthogonal Latin squares have applications in coding theory where they are used to design error correcting codes. They are also used in experimental designs involving more than one factor or treatment. Latin squares and Sudoku variants. Latin squares have inspired various Sudoku variants such as X Sudoku, Hyper Sudoku, and Killer Sudoku. These variants introduce additional constraints and patterns to traditional Sudoku grid, challenging solvers in different ways. Latin squares provide a rich foundation for creating a new and exciting puzzle variations. Latin square design in cryptography. Latin squares have applications in cryptography where they are used to construct substitution ciphers. Substitution ciphers replace plain text symbols with cipher text symbols on a fixed Latin square arrangement. Cryptanalysis techniques can be applied to break these ciphers by analyzing the properties of Latin squares. Latin squares in graph theory. Latin squares can be represented as directed graphs where symbols are nodes and directed edges represents the position of symbols in rows and columns. Graph representation of Latin square are used in graph theory to study their properties and relationships. Latin square graphs have connections to other graph families such as Latin square graphs and Cayley graphs. Theoretical aspects of Latin squares. Latin squares have been extensively studied in combinatorial mathematics. The enumeration and classification of Latin squares are active areas of research. Various conjectures and open problems exist, highlighting the complexity and depth of the subject. Latin Square design software. There are several software tools available for generating and analyzing Latin squares. These tools provide algorithms, visualization, and statistical analysis capabilities for Latin square design. Some popular software options include R packages, Excel, add-ins, and specialized applications. Latin square and Sudoku solving strategies. Solving Sudoku puzzles, applying various strategies based on the properties of Latin square. Strategies include elimination, cross-hatching, and clock and line interactions. Advanced solving techniques such as X-Wing and Swordfish exploit the orthogonal properties of Latin squares. Latin square design challenges. Despite their usefulness, Latin square designs face challenges in practice. Constructing large Latin squares become increasingly difficult as the size grows. Ensuring orthogonality and avoiding bias in experimental designs requires careful planning and consideration. Latin square and Latin rectangles. Latin square can be extended to Latin rectangles where each symbol appears once in each row and column, but not necessarily in every position. Latin rectangles have their own unique properties and applications, such as scheduling problems and DNA sequencing. The study of Latin rectangles is an active area of research in combinatorial mathematics. Latin squares and error detection. Latin squares are used in error detection codes where they provide a means of detecting errors in data transmission or storage. Detection codes based on Latin squares can identify and locate errors, improving reliability and data integrity. These codes find applications in telecommunications, computer memory, and digital storage system. Conclusion. Latin square designs is a powerful mathematical concept with diverse applications. It finds use in experimental design, cryptography, Sudoku puzzles, and many other areas. The study of Latin squares continues to be an active field of research with the new applications and challenges emerging. Thank you for watching. Please like, share, and subscribe.